Hello. In this video we will discuss what a vector is and how we represent it. We will also show how a vector can be used to represent physical quantities in 2 or 3 dimensions, such as position, velocity, and acceleration. Speaking in very general terms, a vector is any object that has both a magnitude and a direction. To make that a bit more concrete, let's show how we visually represent a vector. We represent a vector with an arrow. The direction of the arrow is, well, the direction of the vector, and the length of the arrow represents its magnitude. For instance, we could have this other arrow over here that is pointing in the same direction but is much shorter. This second arrow has a smaller magnitude than the first, though it does point in the same direction. Mathematically, we usually represent a vector in terms of its x and y components. If a vector has only an x component, it will be an arrow facing either right or left. If it has only a y component, it will be an arrow facing either up or down. If the vector has both an x and a y component, then it can point anywhere. Its direction depends on the proportion of x and y. In fact, we can visually see that our arrow consists of an x and a y arrow. Therefore, we often write a vector as a pair of values, with the first one being the x component and the second one being the y component. This is much like coordinates that you are familiar with. We often write a vector as some letter with an arrow on top of it, like this. Now that we have some sense of what vectors are, let's look at how we can represent physical quantities in 2 dimensions as vectors. Let's start with velocity. If we have an arrow representing velocity, the length of the arrow corresponds to the speed of the object. If I had another velocity vector like this, then that object will be going much faster. The direction of the arrow, of course, points in the direction that the object is moving. We can represent this velocity vector as 2 separate movements, one in the x direction and the other in the y direction. Similarly, we can also talk about an acceleration as a vector. The direction is, again, the direction in which it is accelerating. This means that an object experiencing this acceleration will turn towards this direction. If it is already in that direction, then it will speed up. The magnitude of the acceleration tells us how strong the acceleration is. Finally, let's talk about position as a vector. This might be a bit less straightforward. After all, you would probably think that position is a single point in space, and therefore should not have a direction or magnitude. However, we do represent position as a vector because we have some origin of our coordinate system, and we represent position as where the object is in relation to that origin. Therefore, the position vector points from the origin to our object. The direction of the vector is the direction of the object relative to the origin. The magnitude is how far away the object is from the origin. And that is it for this video.